Hi, everybody. We just went through a Newton's law calculation of the gravitational field of Earth, and we used the mass of the Earth and the average radius of the Earth, since the Earth isn't a perfect sphere. And we calculated a field strength of about 9.83 meters per second squared. And that's pretty close to the 9.80 we've been using all year, but it's not exactly it. And I think the reason there's a discrepancy is worth talking about. And it's already been explained to you by Professor Patterson-Hume, who was one of the guys in the frames of reference video. It's because of the Earth's rotation. When you're on the surface of the Earth, you're an object in motion, and Newton's first law says you tend to stay in motion in a straight line. But because the Earth is spinning, you're constantly turning, and that causes you to feel like you're being thrown outward a tiny bit. Now, not very much at all. To demonstrate this, though, and to show it's a fairly real effect, I wanted to invite a friend here. So I've got Abraham Lincoln. We're going to bring him home to Illinois there. Hello, Lincoln. And we're going to give the Earth a little bit of a spin. So the Earth rotates, and not surprisingly, Lincoln stays on it, because the Earth's rotation is at a moderate enough pace, and the Earth is so big that it doesn't overcome the force of gravity. In this case, it doesn't overcome the force of the masking tape, and it stays put. But if the Earth were to spin faster and faster, he would go flying. And I want to see if I can cause that to happen. So we'll give the Earth a good spin. And sure enough, he goes flying outward. So that outward motion in a straight line that would occur if Earth spun fast enough to fling us off it, that is the reason that we feel like we weigh slightly less than we actually do.